enter Indiana Avenue to see what might be wrong with this building. Now that we've entered a building level, if I scroll down, I can see, similar to the portfolio, that there's a collaborator list. This means that I can invite new individuals to access data just for this building in this portfolio, but when they log into Maalka, they will not have access to any other buildings in the portfolio or to any other portfolios. This allows me to securely create building level accounts for teams that allow us to push updates to these buildings, whether those are progress reports aligned with the Better Buildings Challenge or the first view analysis. This social network around the Maalka ecosystem allows direct integration of CRM tools and to drive mail lists that utilize advanced analytics. In this case, let's go to a building that was not an outlier, Bunker Hill Elementary. Now, similar to the portfolio level, which was a roll-up of all the data across all buildings, at the building we have views that show roll-ups of all data at the building level. In this graphs, we see advanced analytics based on the change point regression. This allows us to view the sensitivity of building performance by each type of meter at different periods of temperature. We see that it looks like electricity starts increasing around 75 degrees, which is quite good for cooling systems. We look at natural gas meters. Look at around 66 degrees, it starts going up. Therefore, the energy signature is quite good for this building. We can start tracking energy use intensity metrics year over year. Maalka automatically normalizes this information. Maalka ingests weather information for each building, so you can start doing advanced analytics like the change point regression and temperature sensitivity. We can do dynamic measurement and verification, where we develop models based on different time periods and then apply those models to future time periods. In this case, the green means these are energy savings because the model anticipated at the temperature of this month, the building would use a certain amount of energy, in this case 108,000 kilowatt hours, but it actually used only 70,000 kilowatt hours for a savings delta of 37,000 kilowatt hours. This is based on the change point model, which aligns with the IP-MVP option C protocol. This type of analysis is dynamically conducted for every meter in the building. You'll see the model is developed for the natural gas resource value as well as electricity resource value. Maalka allows you to interactively zoom in and take deeper dives into which months you might have outperformed the model or perhaps wasted energy. Any other data that is being collected in Maalka automatically gets displayed. Users can request configurations in different styles. Now, for each building that is part of a program, Maalka also has dynamic validation. If I'm in the electricity resource meter for this building, I can automatically change the type of units that I'm working with. You can see the BEADS compatible term, which is extremely important when engaging third-party developers. And we can see the quality of the data for each meter at this building. In this case, there's significant failures for data changes between year-over-year data changes. In this case, scroll all the way down, you can identify these exclamation points, which signify data errors. Large data change from August 1st, 2013, 35%. So we can see month to month, this was quite a large change. And the system picked it up and flagged it as a potential error that could be overwritten or confirmed. This type of analysis is actually conducted for each meter and each field in the building. So we can segment actual accountability in order to have different users with different permissions address these issues. And it actually extends this to fields, not just meters as well. For instance, this is construction status. There's no validators that are configured for this data, which was set in the program level. And there's ways to dynamically change these, and I can save it if I wanted to. I'll do it. Furthermore, at the building level, we're able to actually load files. In this case, if I wanted to say add a PDF of DC's energy benchmarking information. I can select it and submit it, and that will actually save this entire document, which I can later download and view. This way we can store resources for buildings, specific buildings, that can be accessed by users with the appropriate permissions.